As I mentioned back in the first section, the unit vector is something we are going to be using a lot. And a unit vector has a magnitude of 1. That is really key, a magnitude of 1. So our first goal with dealing with unit vectors is finding unit vectors. So unit vector, magnitude of 1, those two things, you have to know that they're tied together. So here's the process we are going to use to find the unit vector. The first thing we're going to do is we're going to find the magnitude. The second thing is we're going to divide the original vector that's written in component form by the magnitude. And then finally, if we want to check our work, we can find the magnitude of the vector, and it should equal 1. So first we want to find a unit vector in the direction of 2, -3. You can see right here we're already in component form since we're in that less than greater than format. But if I were to have an ordered pair such as 2, 1, and 7, 8, I'd first need to convert that to component form. So since I'm in component form, we're going to find the magnitude, then we're going to divide our original vector by the magnitude. So first of all, the magnitude, which we know is going to be the horizontal component squared plus the vertical component squared. So 2 squared plus -3 squared, which is the square root of 13. Our unit vector then is we're going to divide the original vector by the magnitude. So to find the unit vector, we're going to take our original vector in component form and we're going to divide by the magnitude. And if I divide by the magnitude, it's the same thing as when I multiply in by a scalar. This is the same thing as 1 over the square root of 13. And when you multiply by a scalar, you multiply each component piece by it. So I'm going to have 2 over the square root of 13, -3 over the square root of 13. And then finally, to simplify my unit vector, I'll rationalize the denominator. And there's my unit vector. 2 square root of 13 over 13, -3 square root of 13 over 13. Yes, these unit vectors are going to look messy, so don't be frazzled by those fractions and square roots. Just do another one. Find the unit vector in the direction of v equals -1, -8. Once again, we're already in component form, so I can go straight to the magnitude, which would be -1 squared plus -8 squared. That's the square root of 65. Second piece for the unit vector then is we are going to divide each component by the magnitude. So -1, -8 in component form already. Divide by the square root of 65, which means each piece is divided by the square root of 65. And then finally, we'll rationalize the denominator. The last skill that we've got here on this page is looking at standard unit vectors and linear combinations. Once again, we got a couple more vocabulary words. Unit vectors, we said, had a magnitude of 1. The standard unit vectors are 1, 0, and 0, 1. And we represent standard unit vectors by I and j. And what that's saying is if I were to plot these vectors on the coordinate plane, so I of 1, 0, that means I'm going 1 unit out. That means the length here of this unit vector is 1. And then j is the unit vector 0, 1, which means I'm going 1 unit up. So the length or the magnitude of that is going to be 1. So these standard unit vectors are little unit vectors that each have a magnitude of 1. And the last piece we want to do is we want to write each of our vectors as a linear combination of i's and j's. So we want to break down our linear combination, or excuse me, we want to break our component form into a linear combination. So here I've got a a vector in component form, I want to put it as a linear combination of i's and j's. So I know the first piece here is my horizontal component. The second piece is my vertical component. I want to know how many i's and how many j's I've got. So here with this vector 3, -4, I want to know how many 1 zeros and how many 0 1s I get in. And to write this in a linear combination, it's actually very straightforward. It's going to be 3i minus 4j. You take your horizontal component and you write that in terms of 1 0. So right here, 3i is what makes up 3 in components of 1 0. The -4 here tells me I'm just going 4 units down, so I'm just going to have -4 of the 0 1s. So my linear combination of 3 -4 is 3i minus 4j. You notice in the linear combination there is no comma. It's just a plus or subtraction sign in between the two. If I were to do another one, 2 -9, that's going to be 2i minus 9j. And you'll sometimes even see these guys written with these caps on top, indicating that we're talking about unit vectors. And specifically, unit vectors, that's a linear combination. If I really wanted to, I could check my work on these by plugging in what I and j are. I know I is 1 0 and j is 0 1, so I could put in those values for i's and j's, distribute the 2 in, so I would have then 2 comma 0, and then back here I would have 0 and -9, and then when I add my original together, I can see I end up with the vector I started with. So you can always check your work by putting in the 1 0 and 0 1, but realize that if you've got a vector in component form, all you need to do is place an I and a j in there and then have the correct sign in between.